All right, so this is going to be the review video. I will go through all of the Jeopardy questions except for the Final Jeopardy. I never go through the Final Jeopardy because those ones are usually typically the hardest of them, and I want you to keep trying to persevere and work through until you get to that answer. And those are usually maybe what the extension questions would be like on the assessments that's given to you, so kind of like the extra credit question. And it's something that I think is just challenging you a little bit more. And so for those questions, whenever I do this Jeopardy, I usually don't go over them because it's something I want you to try and look up on the internet or keep working and trying to think of different ways, work with another classmate, try and use resources around you to get that answer. All right, so let's go ahead and start moving on to the first question. And I am going to go through these kind of quickly because by now we have done a bunch of these, and this shouldn't be you learning it, but you just checking to see, well, what did I do that was different than yours? And how did I get it right and you got it wrong or whatever. So it's not necessarily a way to teach, but it's a way for you to check your work. All right, so for this problem here, first identify what we have, and it says parallelogram. And I know the area of a parallelogram is base times height. So the two things I need are my base and my height. Well, the first thing I'm going to look for is that dotted line that gives me the right angle. And here's that dotted line that gives me the right angle here. And remember, whatever two bases it is connecting, that is the base that you have to use. So it's touching these two here, these two blue bases. Now remember, if you're having trouble with seeing these, highlight your opposite bases the same color, and then look and see, well, which one is this height connecting? And it's clearly touching the two blue bases. So that means that this dotted line is going to be our height. So 4 is our height. And then the distance or the length of the blue base is going to be our base that we're using, 7, because this height is connecting those two bases. We cannot use 5 as our base because this height is not connecting the two pink bases. So then we will just go ahead and plug it in. So area is equal to 7 times 4, and our area is equal to 28. And whatever units are provided for you, make sure that you are writing them units squared. All right, this is what I want to see on your assessment. Some of you just were not showing me your work, and that's something that needs to change. So it's something that I'm going to be a little more harsh on when we're doing this because I need to make sure that you're showing me exactly what it is that you are doing. All right, let's move on to the next question. All right, so for this one here, it says find the area of the triangle. So first off, write the formula for area of the triangle. And now after you write this, we're going to say, okay, let's see. We need to solve for our base and we need to solve for our height. So remember, our height is going to be that dotted line with that 90-degree angle. So here is our height. All right, there's our 90-degree angle. And in a triangle, it's connecting a base and the opposite vertex. So you see that here is where the vertex it is touching at. So that means the base that is not touching that vertex, the only one that's not touching it, that has to be the base of our triangle. So in this case, our base would be this 12 because this green side is 12. So our base is 12, and then our height is the distance from that base to the opposite vertex. So in that case, it's going to be 4. So then we just plug it in. Area is equal to 1/2 of 12 times 4. Well, 1/2 of 12 is 6, so area is equal to 6 times 4, or area is equal to 24 units squared. All right, so remember, in a triangle, it's not that it's going from one base to the other, it's going from a base to the opposite vertex. So the way I would suggest that you do this is identify, well, where is that line going? Where is our height going? Well, here's our height. And it's touching this vertex. So highlight this vertex a color. And then say, okay, what is the only base that's not touching that vertex? And that is this base here. So that means this has to be the base we're using for our area. All right, now let's move on to the next question. All right, so for this one, if you're having trouble identifying which base you're using, then highlight your opposite bases. All right, I have plenty of colored pencils that you can use during your assessment to help you with this if you need it. So the opposite sides are the ones that we are highlighting because those are the sides that correspond to each other. They're the sides that are the same distance, they're the sides that are parallel, etc. All right, so now what we will do is I'm going to highlight our height. And here is our height. It's the dotted line with the right angle. So then I look and see, which two sides is this touching? Well, it's clearly touching the two blue sides. It's not touching this red side here at all. There's no imaginary extension of that red side that we can say, okay, this is where it's eventually going to meet. So it is touching the two blue sides. So our area of a parallelogram is equal to base times height, or base in this case is going to be the length of the blue side because that's the two bases that the height is touching. So that would be 5, and our height is equal to 4.8. So now we just go ahead and plug it in. Area is equal to 5 times 4.8. And if you're not sure how to do this, we can then do 4.8 times 5. Well, 5 times 8 is 40, so we put the 0 down and carry the 4. 5 times 4 is 20. We add the 4 that we carried, so it's 24. And then we say, well, we have one total number that's a decimal, so that means we need to move this decimal one place value. So that is 24. So our area is equal to 24. And since we have units now, we will say centimeters squared. All right. And if you need any more help on this, please reach out on Remind. I sent all of your parents an email as to how they could sign up for Remind if they'd like to, so you can get help. So if you need help, just send me a message. All right. So for this next problem, we see we have a triangle. So area is equal to 1/2 base times height. So we need to solve for our base and we need to solve for height. So the thing I'm going to do now is I'm going to identify my height. So here's the dotted line that's going from a vertex to the opposite side that has our right angle there. So that means that this point here, that's the vertex it's touching. So I look and see, well, what is the only base that this vertex is not touching right now? And the only base that it's not touching is this base down here. So that means that my height is going to be the 6. I'm sorry, put that in the wrong one. And my base is going to be the 7. All right, on your last assessment, some of you were trying to add this 2 with this 7, but this is not part of our actual triangle. All right, this is an imaginary extension to say, well, where would we meet at a 90-degree angle? Because it has to meet at 90 degrees. So it's impossible for me to draw a line going from this vertex and touching the actual base where it's meeting at 90 degrees. So in order for us to show that 90 degrees, we need to show this imaginary extension. All right, then we just plug in after we find our base and our height. So it'll be 7 times 6. Well, 1/2 of 6 is 3, so it becomes 7 times 3, and that is equal to 21. We don't have any units, so we will write units squared. All right, now for this next section, we're asked to solve for x. We're not solving for the area necessarily anymore. We might have to, depending on the problem, but we're asked to solve for x. So let's look at the information that's given to us. Well, it says solve for x if the area of the triangle is 60 units squared. So I know our area is equal to 60 units squared, right? That is very important. I know we have a triangle because it tells me that here, so I'm going to write my formula as 1/2 base times height. So now I look and see, well, where is that x at? So here it is right here. And what is that representing? Well, here is that height going from the vertex to the base. So that means that our height is going to be 10, and our base is what we're trying to solve for. That's this x. So base is equal to x. So I'm going to substitute what I know. So my area is equal to 60. So it'll be 60 is equal to 1/2. My base is x. My height is 10. So 1/2 of 10 times x. I will reduce, or I will simplify this side first. So 1/2 times 10 is 5. So 60 is equal to 5x. Then in order to solve for this, we will this 5 and this x are being multiplied. So we do its inverse operation, which is division. And that means x is equal to 12 units. And if I want to check my work, over here off to the side, over here off to the side, I can do 1/2 of 12 times 10. Well, 1/2 of 12 is 6. 6 times 10 is 60 units squared, which is what the question said our area was to begin with. All right, so you can always check your work with this. All right, now let's move on to the next one. Okay, now this question on the last assessment seemed to cause a lot of people some issues because this one, it doesn't flat out say what the area is. For the triangle, it said area is 60 units squared. For this one, it just says solve for x. So we need to first see, well, in order for me to solve for this x, because let me highlight these sides. So here are the two opposite sides. And here are these two opposite sides. In order for me to solve for x, I need to know what the area of this parallelogram is first, because I can see that this x is the height between the two pink bases. So I look and see, all right, well, I can't solve for the formula, the area of the triangle, or the area of the parallelogram looking at the pink sides, but let me see what other information they give me. And they give me this dotted line here with this right angle. So that means this 8 also represents the height of a parallelogram. So our area is equal to base times height, and I know that my height is equal to 8. Well, what is the base equal to when my height is 8? Well, this green line is connecting the two blue bases, so that means when our height is 8, our base is 6. So then that means our area of this parallelogram is 6 times 8, which is 48 feet squared. So now I know the area of this parallelogram. So now I say, okay, well, I can solve for that missing height then, because this dotted line is connecting the two pink bases, and I know that my base of my pink is equal to 12. So my area is equal to base times height. My base is equal to 12. My height is my x. And I just solved that my area is equal to 48. So regardless of which way I'm looking at this, if I'm looking at this shape going up or if I'm looking at it going over, it's still the same shape. So the area doesn't change. So I know that my area is 48. My base is 12. And my height is x. So now if I want to solve for this x, I get rid of the multiplication by division. And then that means that my x has to be equal to 4 feet, or the height of the parallelogram when we're looking at it in this direction is 4 feet. Right? So this one, if it doesn't give you the area flat out, then you have to say, well, how can I solve for the area? Because without it, I can't actually solve for this question. All right, so that's something that could very well appear in this assessment, again, since a lot of people seem to struggle with that part. All right, so now we're going to move on to the composite figures section. That's mainly what this assessment is going to be on, as we've already assessed a little bit on the other parts. But whenever I see some common misconceptions and we go over them again, it is something that I do like to reassess sometimes, just to see if you guys are able to get it the second time around. So when we look at these composite figures, remember the first thing that we need to do is we need to break these off into different shapes. We're trying to break them up into triangles, squares, rectangles, and see if we can then figure out the area of those figures and add them up. And remember, there's multiple ways that you can do this, right? There's not just one way. I'm going to go through and try to do different ways for each one if I can, and not just keep doing the same one. Because on some of these questions on your assessment, it will say, do it in multiple ways. So this first one, I'm going to look as if this rectangle did not get cut off. So I'm going to look at this as an entire rectangle, right? And like I said, draw these images off to the side so you can fill in, so you can easily fill in what their dimensions are. So if I look at this entire rectangle, I see I have 20 and 17. So if I'm going to solve for the area of this rectangle, I know that my area is equal to base times height. I know that my base is then going to be equal to 20. My height is equal to 17. So my area is equal to 20 times 17, which my area is then equal to 340. But we solve for this entire figure. We don't want this entire figure. This little portion here in this top right corner, let me redraw this so that way it's not covering the number. This portion here in this top right corner is not actually part of our area that we want to solve. So I'm now going to break this rectangle off to the side. I'm going to fill in what I know. This is 12. It tells me that. Right? This entire side I know is equal to 17. Well, if this is 10 and the entire side must be 17, that means this missing portion must be 7, because 10 plus 7 gives us 17. So I know that this is equal to 7. So now I'm going to go ahead and solve for the area of this red part. So our area is equal to base times height. My base is equal to 12. My height is equal to 7. My area is equal to 12 times 7. So my area is then equal to 84 meters squared. Let me write this in as meters squared. All right, now, this portion is not actually part of the area we want. So we need to remove it. Well, when we're removing, we will subtract. So we will then do 340 minus 84, and that will give me 256. So that means my area of this figure is 256 meters squared. All right, so if you have trouble with multiplication, reach out to me, look it up online, but I'm not going to go through each step just for interest of time for this video. All right, let's move on to the next question. All right, so we have a composite figure. Let's first draw out our two shapes. I see this triangle up here, so let's solve for the area of this triangle. I see that its height is equal to 6. And since this is a rectangle, I know that the opposite sides have to have the same distance. So if this is 9, that means this is also 9. So I know that my area of a triangle is 1/2 base times height. I know that my base is equal to 9, and my height is equal to 6, because here's where our dotted line with the right angle is touching the vertex, and the opposite base is the opposite side that does not touch is our base. So then our area of this triangle is 1/2 of 9 times 6. Well, 1/2 of 6 is 3, so 3 times 9 is equal to 27. Right? Then the other shape that I see here is this rectangle that I'm going to now draw in red. So I will draw this over here. We have 9 and we have 8. So our area is equal to base times height. Well, my base is 9, my height is equal to 8. So our area is equal to 9 times 8. Our area is then equal to 72 meters squared, and this is 27 meters squared. And now, unlike the other one, we're not removing anything. We are actually saying that these two pieces that we have are both part of our area, so then we need to add them together. So it'll be 72 plus 27, and that will then give me 99. So then our overall area is equal to 99 meters squared, because we are adding these two together. All right, let's move on to the next question. All right, so this one might be a little bit harder for some of you, because you see all these slants, you're like, oh, I don't really know exactly what these shapes are. But if we can look at these sideways, see if I can just draw a quick little sketch. This is actually two parallelograms. So we just have two parallelograms that we need to solve for. So it's nice and easy. We have this one here in black. So I'll draw this one off in black. We know that our height, this dotted line with the right angle, is 12. And then remember, parallelograms, opposite sides have the same length. So that means the three sides I'm going to draw in red now are all the same length. So that means if this is 25, this one's also 25. So since this line, dotted line with the right angle, is touching these two red bases here, that means that this 25 will be our base. So we can just say our area is equal to base times height. Our base is 25, and our height is equal to 12. So area is equal to 25 times 12, or our area is then equal to 300 meters squared. And then we also have this parallelogram. And once again, this height is touching these two sides. So this parallelogram also has a height of 7. Doesn't also have a height of 7, because the other one doesn't have a height of 7. But its base is also 25, because all three of those lines that were connected by our heights are all the same distance. So then this height here is equal to 7. So area is equal to base times height, where my base is equal to 25. And my height is equal to 7, so area is equal to 25 times 7, or area is then equal to 175. So now, once again, these two images are being combined. We're not removing anything. We didn't find the area of something that we didn't need. We found the area of both parts that we need. So in the end, we will add these two together. So our area is equal to 475 meters squared. All right, this one may look like it's really hard, but it's actually the easiest of the ones that we've done so far, I think, which then makes me question why I put this at 800. But I think it could cause some issues because of the way that these triangles are looking. But it's really easy. We just have this triangle here. So I'll draw this off. And we have this dotted line that's connecting this vertex with this imaginary extension of this side. So that means this green side here that is 20 is our base, and then this here is our height, that is 23. So our area is equal to 1/2 of base times height. Our base is equal to 20. Our height is equal to 23. So area is equal to 1/2 of 20 times 23. So area is equal to 10 times 23, or area is equal to 230 meters squared. And then down here, we just have another triangle that we just solved for, all right? And just like this one here, it's already giving us our base and our height for us. So here we see that we have this dotted line that's touching this vertex, and it's going to meet at a 90-degree angle with the imaginary extension of this side. So that means this side here has to be our base. Well, we already know that that is 20. And it tells us that the height here is equal to 9. So this one's actually a little bit easier than the one that we were just, than any of the other ones that we're doing. But the reason why it may be difficult is because you might not realize that those lines going up and down, these two lines here, that they're giving us the height, and both of our triangles actually have the same base. So here we will then say our area is equal to 1/2 base times height. So our base is equal to 20, our height is equal to 9, area is equal to 1/2 of 20 times 9, area is equal to 10 times 9, area is then equal to 90. So now, once again, these two images are not, we're solving for the actual area here. We didn't create this image that has parts that aren't needed, so we need to just add these two together. So our area is equal to 320 meters square. All right, so for this problem, I probably would have done it the same way that I did the first one, where I drew the entire shape around the outside and just got rid of these two triangles. But because I want to show you different ways, I'm going to then just break this down for you a way that might not necessarily be the easiest, but just to show you another way that we can do this. All right, so once again, I'm just going to break out all the shapes that I have. So the first one I have here now is this blue rectangle. All right, I see that this length is equal to 18, and I see that this is equal to 22. So the formula for area of a rectangle is equal to base times height. My base is equal to, let me write this underneath because I might need a lot more space on the side than what I normally do. But my base is equal to 18. My height is equal to 22. So then my formula for area of a rectangle here is 18 times 22, which is then going to give me 396 meters squared. All right, so I just solved for this area here. Now I'm going to move on to this trapezoid. Now remember, on this assessment, our standards talk about breaking things down to squares, rectangles, and triangles. So if you know the area, the formula for area of a trapezoid, that's great. But on this assessment, you can't use it, all right, because our standard that we are assessing says specifically for you to break it down into triangles, squares, or rectangles. All right, so the first thing I'm going to do then is I'm going to break down this little rectangle that we'll have here because it clearly states that this base is going to be equal to 13. So I'm going to break this rectangle out. Let me just draw a line here separating this. So here I have my base of 13. It tells me at the distance, because you can't really see the dotted line now, but it tells me that the distance between the two bases is 7. So I know that this is going to be equal to 7. So area is equal to base times height. My base is equal to 13, and my height is equal to 7. So then I would do area is equal to 13 times 7, and that will then give me 91 meters squared. All right, now I create these two congruent or equal triangles off to the side. So I'm just going to solve for the area of one of them, and I can just double it to get to the area of the other. All right, so now what we need to think about, let me just box this off, is this entire side length from here, let me give me a little bit more space up here. This entire length from here to here is equal to 18. I know that this is equal to 13. So that means that in order for me to find this distance from here to here and here to here, remember, we will do 18 minus 13. So that means that those two side lengths combined is equal to 5, and since they're both the same, we will divide it by 2, which means they are both equal to 2.5. All right, so now I'm going to start by drawing this triangle off to the side, where I know that my base is equal to 2.5. The height is going to be the exact same height that was for our rectangle here. So that will then be equal to 7. So area is equal to 1/2 of base times height. My base is equal to 2.5. My height is equal to 7. So then I will do area is equal to 1/2 of 2.5 times 7, which 2.5 times 7 is equal to 17.5. So area is equal to 1/2 of 17.5. Then I will divide that by 2, and my area is equal to 8.75 meters squared. Now remember, I have 2 of these triangles, so I will then just multiply this number by 2. And I know that the 2 triangles have an area of 17.5. So I will add these 3 together. So 396 plus 91 plus 17.5. And that will then give me an area of 504.5 meters squared. All right, this one is a little bit trickier, a little bit harder because there's a lot more work that goes to it. If you did it the other way, though, that I was talking about, where you made this into a rectangle and then you just got rid of these 2 triangles, I do think it would have been a lot easier, a lot less work. But I want to show you different ways you can do this. All right, now we're on to our last 2 questions. So we want to find the area of the shaded region. So that's just in between these 2 here. So the first thing I'm going to do is look at this entire rectangle, or in this case a square, and I see that my sides are 5 and 5, so area is equal to s squared. My side is equal to 5, so area is equal to 5 squared, which in this case is 25 units squared. And then I'm going to solve for the area of this inner part, because this is not actually included of it. So I need to get rid of this from our main figure because it's not actually including. So first let's fill in our sides. It is 3 and 2. So area is equal to base times height. My base is equal to 3. My height is equal to 2. So area is equal to 3 times 2, or area is equal to 6 units squared. So since we're removing it from this entire figure here, we're taking this out. We need to subtract them. And 25 minus 6 will give me 19 units squared. So that means the blue area is 19 units squared. All right, and now the last question. So the first thing I'm going to do is I'm going to break this composite figure down into 2 shapes. So I'm going to look at it as just this rectangle here. That's green. And then I will focus on this little guy that's on the inside. So first, let's fill in what we have for a rectangle, where it tells us that this side is 10. So I can fill in 10 here, and it tells me that this is equal to 3. So I can put 3 here. So this rectangle, if it was all shaded in, I know that my area is equal to base times height. My area is equal to 10 times 3, and my area is equal to 30 centimeters squared. Okay, now you can do this next part one of 2 ways. I can then remove this little square on the inside now, immediately, or I can do it at the end after I add my areas together. I'm just going to do it now. So now I have this little block that I need to remove from our green area. Well, this is a square, so side squared. Well, my side is equal to 2, so area is equal to 2 squared, or in this case, my area is equal to 4 centimeters squared. Now remember, we're removing this piece. We're taking this out of this green area because it's not actually included from it. So off here to the top, I will do 30 minus 4, which means this green rectangle has an area of 26 centimeters squared. All of this here colored in. Right, now we will look at this little portion down here. So let me just box this off. So we have this rectangle. Now we need to fill in this information. Well, let me erase what I have drawn on here so far so we can look at this a little bit clearer. Well, I know from here to here is equal to 3 because of this, and the entire length is equal to 5, then that means this missing part here must be equal to 2 because this 2 and this 3 have to add up to 5. So I know that this is going to be 2. And then if this entire piece from here, let me use a different color. Let's do purple. From here all the way over to here is equal to 10. Can we see that? Yes, we can. And I know that from here to here is 7, as it tells me, then what is this missing piece? What is this missing part that's over here? And that will then be 7 or 10 minus 7, which is 3, or 7 plus what number gives me 10? So that means this is equal to 3. So my area of a rectangle is base times height. My base is 3. My height is equal to 2. So area is equal to 3 times 2, or my area is equal to 6. So now I solve for the area of the green shaded region, which is 26, after we remove the red part, because that was this hole that we're taking out. And the area of my blue is 6, so that means I will do, let me just write it off here, 26 plus 6. So that will give me an area is equal to 32 centimeters squared. All right, and that is our final answer, and that is it for this video. You are able to skip around through this video, so you don't have to watch the whole thing, but it's here if you need it.